Understanding Insulating Barriers for Acoustic Performance in Architectural Design. Welcome to Building Knowledge 101. In this video, we explain how acoustical performance can be improved by adding or creating barriers to disrupt the pattern of sound waves passing through various materials in an aluminum framing system. As stated earlier, STC and OITC performance can be improved by adding or creating barriers to disrupt the pattern of the sound waves as they pass through the various materials. In an aluminum framing system, the overall system performance can be improved by modifying the glass infill units being used. This first one is your typical insulating glass unit. It's a 1-inch unit. It has an STC rating of 35 and an OITC rating of 30. This unit now introduces a laminate layer. Here are the sound wave patterns disrupted by having to navigate through varying thicknesses and medium as they try to pass from the interior to the exterior. This improves the STC rating to 41 and the OITC rating to 32. This third unit has 2 laminate units and is disrupting the pattern even more, yielding an STC rating of 42 and an OITC rating of 33. The fourth unit is 3 lights of 1/4-inch glass with 1/2-inch airspace between them. This yields better performance than your typical 1-inch insulating glass unit, but because these are consistent lights of glass, the pattern is not disrupted as much. So they improve the performance, but not as much as adding laminate layers, which vary the thickness and the density of the medium that the waves are passing through, and it doesn't degrade them as much. But triple glazing on top of 1-inch insulating glazing does improve performance. And once you combine these units into your aluminum framing system, you can anticipate overall performance to decrease by about 5 to 6 points. You can't reach the STC or OITC level that you need with just 1-inch insulating glass units. You might need to look for a system that will allow you to add additional layers of glazing to disrupt the sound waves. Here are 2 examples of curtain walls that add additional layers of glass to the daylight opening, which adds barriers to the sound waves. A standard curtain wall with a typical insulating glass of STC of 34. Based upon what your acoustic consultant tells you, this system might not offer as much protection from exterior sound as required near an airport. The system on the right has a 1-inch insulating glass unit with a laminated outboard light and a laminated sole sash to the interior. Adding this additional sole sash to the interior increases the overall system performance considerably. This yields an STC of 46 and an OITC of 33. You can see that adding the second layer of glass with a stop and sash will greatly improve the acoustical performance of the system. The detail here in the upper left is a dual glazed curtain wall system. This is a curtain wall that has glass pockets on the exterior and on the interior to maximize the disruption of sound waves passing through it. This dual glazed configuration yields an STC of 52 and an OITC of 42. It is best to engage an acoustical consultant to work with you to determine the STC and OITC levels that you need for your specific project. But as you can see from examples here, going from a standard curtain wall in the center with an STC rating of 34 to a sole sash on a standard curtain wall, moving you to an STC of 46, and then lastly to a dual glazed curtain wall with 2 layers of insulating glass unit with laminate layers in them, that bumps your STC performance to 52. So you have lots of options that you can add on to a standard curtain wall, move to a more unique dual glazed curtain wall specifically designed for improved acoustic performance. You have a number of different options available to you based upon the sound performance dictated by your acoustical consultant. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.